Okay, this is Mr. Peterson. I'm going to cover vertex form with you. It's one of the formats for a quadratic equation. You're going to see parabolic graphs, and there's actually two formats. The first format is called vertex form, and then there's standard form. Let me give you an example of each. So with vertex form, it might look like this. And with standard form, you're going to get something that looks like this. Now, what both of these formats share in common is a second power, and that's what gives it its shape, the parabolic shape that we associate with quadratic equations. So today's lesson is really only about this format. It's about vertex form. And I'm going to start by just telling you what these different letters are. The number in front, I'm looking here in the example of the 3, we call that the A value. That'll tell you how stretched or compressed the graph is in a vertical direction. So for instance, the 3 that I have in my example would make it 3 times taller than it normally would be. And then on the inside, you have the distance that it translates to the left or right, and remember that's always the opposite. And then up and down translation movement is handled by that last number. So because parabolas normally start centered at the origin, I'll give you a little picture to think about. You're starting at 0, 0 and moving it, in this case, to the left 4 and then down 7, which would take you to -4, -7. In the end, that will become the new location of the vertex. So we're going to call the vertex HK, and that's still an x and a y value, like points always are, but it's a special x and a special y. It's the one at the vertex of the parabola. So in the formula, we have the opposite of h. That minus sign in front, if you're looking at just that part of it, is negative h, but it's better to think of it as the opposite of the value of h. So for instance here, that moves 4 to the left, your h will be -4, not +4. And then the k value is right here, and there's no change on that one. So here the k value would be -7, and we'd have a vertex of -4, -7. Okay, so the parabola's vertex is at hk. That's just an arbitrary choice. We assign h for the x value of the vertex and k for the y value of the vertex. So in this first exercise, we're supposed to decide the transformations that happen to the original function, x squared, and that would just be a little parabola at the origin, centered at the origin. And then we're supposed to identify the vertex point. So if you look right here, inside the parentheses is where you start, and that would be a movement to the right, 3 units. Remember that inside the parentheses always goes the opposite way, so h is going to be 3, not the -3 that you see in the parentheses. And then we turn our attention to the outside multiplication, and that's a vertical stretch. Anytime you have a number out there that's bigger than 1, it stretches. So here the y values are all going to be multiplied by 2, which would have the effect of making it twice as tall. And last but not least, there's this 1 added to it after the fact here, so that makes it go up 1 unit. And now we're going to turn our attention to finding the vertex. Well, the h value, you're going to find its opposite right there. So if the opposite of h is -3, then h must be 3. And then the k is simply that number at the back. So you can see that vertex located at 3, 1, 3 to the right of the origin, 1 above the origin. And this thing is stretched. It's taller than it normally would be by a factor of 2. Okay, similar exercise down here. Inside first, that's left 4 units. Remember, adding makes it go to the left. And the second thing is this negative sign on the outside, and that's really like multiplying by -1, and it has the effect of a vertical reflection. Now you can answer it that way, a vertical reflection, when you see that negative sign, or you can say reflected, this is just an alternate way of saying this, reflected over the x-axis. Either way is fine. And the third thing that happens is that is affected by that +6, and that moves it up 6 units. Now, to make it really easy for you to see this, I'm going to color code the vertex on this thing. So give me a second to rewrite it. H of x equals the opposite of x. And I'm going to put, let me change this to green here. I'm going to put the opposite of h in green here. And then I'm going to put the k value in red. So now when I come down here and put the vertex in, hang tight. When I put the vertex in, I take the opposite of that +4, and then I go up 6, which takes me 6. So if you look right here, you can actually see that that vertex is 4 to the left of this origin and 6 above the origin. So it moves to the left and up, and then gets flipped upside down. Actually, it moves to the left, gets flipped upside down, and then get lifted up. So that's the order. Okay, page 2. On page 2, we're given some problems here where they give us the vertex and another point, and they want to know what the equation of this parabola is. Well, we do know that the a value has to be negative when it points downwards like this, but other than that, we got to figure out what a is. So the vertex is always h and k, and this other point we'll just call generic x and y, and we're going to plug that into the vertex form here. So give me a second to copy this. And now I'm going to plug in all the given information. I know what y is, that's 4. I don't know what a is yet. I'm going to find that one. X is 5. The opposite of the h is -3 or -3. And then the k is 6. So I have to solve for a here. And I'm going to take all this stuff right here and do it all. So first of all, 5 minus 3 would be 2. And when I square that, I get 4. So let me write down everything else. I'll subtract 6 off both sides. I'm out of room, so let me come over here with it. Subtract 6 off both sides. And divide both sides by 4. And now we know a is -1/2, which would be a vertical compression, and then the negative would do a vertical reflection. So we have to write this big equation, and I'm going to write the whole thing first of all, and then I'll put the template down that we have to fill in. And the template on this one looks like this. I'll fill it in with green here. We know a is -1/2. The opposite of h, if you remember h was 3 up there, So the opposite of h is going to be -3, and the k is 6. So that's the equation of that parabola. And you could actually check this by graphing it on a graphing calculator and using the trace key to see if those 2 points that are mentioned up there, 3, 6, and 5, 4, are actually on the graph. Okay, so let's do it once more here. And what I want to point out here is that you really don't need the picture to be able to do this. You just have to know which point's the vertex and which point's just another generic point. So we have the vertex marked with a V, that's H, and this is K. So if you do it over here, this is H, and this is K. But just knowing that V is in front tells me that's H and K instead of a normal, just everyday X and Y. We'll put that instead on this one over here. So we're going to go through the same process again. Let me write down vertex form. And you plug in all the numbers that you know. Use 22 for Y, 4 for the X. The opposite of H in this case is +2. And the K is -5 or -5. Now this stuff here, you want to think of all this as being something you can just do all at once. You start inside the parentheses. 4 + 2 is 6. And when you square it, you get 36. We'll add 5 to both sides. And divide by 36 here. So now you know A is equal to 27 over 36. And you can simplify this fraction by dividing top and bottom by 9, and you get 3/4. So now you're ready to fill in the template. A is 3/4. The opposite of H is +2. And then you tack K on the end there, and you've got your equation. And you could check this again by graphing this on the Y1 line of your calculator, and then using the trace key to see if these points are actually on your picture. You'll probably have to extend the window up to maybe 20, something higher than 22, in order to see where the cursor goes when you trace. Okay, that does it for pages 1 and 2 of the notes, and I'll continue on a separate video with the rest of the notes.